So, salt, sodium chloride. This is according to Britannica.com. Also known as common salt, sodium chloride, or table salt. Right. These are questions, top questions. Not going to go through them. We could go through them after we've read what's in this article. So it says salt, NaC1, mineral substance of great importance to human and animal health, as well as to industry. The mineral form halite or rock salt, I think it's pronounced halite, Halite, or halite, or rock salt, is sometimes called common salt to distinguish it from a class of chemical compounds called salts. So salt. Properties of common salt are shown in the, click here to see full-size table, right? So this table, I assume, is right. Let's have a look at this. I think that's just the same. Let me just check. Yeah, it is just the same. So we might as well go back to where we were. Right. Properties of salt. Name of compound, sodium chloride. Chemical formula, NaC1. Formula weight, 58.443. Color, colorless or white when pure. Colored splotches, e.g. blue, purple, when impure. Lustre, vitreous. Physical form, transparent to translucent cubic crystals, also powder or granules. I don't know what this is. MOHS hardness, 2.5. Density at 0 degrees Celsius, which is 32 degrees Fahrenheit, 2.17 grams per centimeter cubed. Melting point, 801 degrees Celsius, which is 1,474 degrees Fahrenheit. That's pretty hardy. Boiling point, 1,465 degrees Celsius. That's 2,669 degrees Fahrenheit. Solubility, water, in brackets S, star, glycerol, glycerol. I think that says, oh my God, is that how you pronounce that? S in brackets, alcohol, SS in brackets, with a cross sign. Oh, these are all like, okay, hydrochloric acid, I, and then the, I don't know what symbol that is. Right, okay, there's a key here at the bottom. So the S means soluble. That looks like a Christian cross sign, means slightly soluble, which is SS, and that double cross sign, which is an I, meaning insoluble. All right, so the water is soluble, the glycerol, if that's how you pronounce it, is soluble. The alcohol is slightly soluble, and the hydrochloric acid is insoluble. Right. Salt is essential to the health of both people and animals. Table salt, used universally as a seasoning, is fine-grained and of high purity. To ensure that this hygroscopic, i.e. water-attracting, substance will remain free-flowing when exposed to the atmosphere, small quantities of sodium aluminosilicate. No, I don't think I've pronounced that correctly. Aluminosilicate. Oh, gosh. Tricalcium phosphate, or magnesium silicate are added. Iodized salt, that is, salt to which small quantities of potassium iodide have been added, is widely used in areas where iodine is lacking from the diet, a deficiency that can cause swelling of the thyroid gland, commonly called goitre. I think that's how you pronounce that. Livestock also require salt. It is often made available in solid blocks. The meat packing, sausage making, fish curing, and food processing industries use salt as a preservative or seasoning or both. It is employed for curing and preserving hides and as a brine for refrigeration. In the chemical industry, salt is required in the manufacture of sodium bicarbonate, that's baking soda, sodium hydroxide, caustic soda, hydrochloric acid, chlorine, and many other chemicals. Salt is also employed in soap, glaze, and porcelain enamel manufacture, and enters into metallurgical processes as a flux, a substance promoting fusing of metals. When applied to snow or ice, salt lowers the melting point of the mixture. Thus, large amounts are used in northern climates to help rid through thoroughfares of accumulated snow and ice. Salt is used in water softening equipment that removes calcium and magnesium compounds from water. History of use. In some parts of the Western Hemisphere and in India, the use of salt was introduced by Europeans, but in parts of Central Africa, it is still a luxury available only to the rich. Where people live mainly on milk and raw or roasted meat, so that its natural salts are not lost, sodium chloride supplements are unnecessary. Nomads with their flocks of sheep or herds of cattle, for example, never eat salt with their food. On the other hand, people who live mostly on cereal, vegetable, or boiled meat diets require supplements of salt. The habitual use of salt is intimately connected with the advance of nomadic to agricultural life, a step in civilization that profoundly influenced the rituals and cults of almost all ancient nations. The gods were worshipped as the givers of the kindly fruits of the earth, and salt was usually included in sacrificial offerings consisting wholly or partly of cereal elements. Such offerings were prevalent among the Greeks and Romans and among a number of the Semitic peoples. Covenants were ordinarily made over a sacrificial meal, in which salt was a necessary element. The preservative qualities of salt made it a peculiarly fitting symbol of an enduring compact, sealing it with an obligation to fidelity. The word salt thus acquired connotations of high esteem and honor in ancient and modern languages. Examples include the Arab avowal, "there is salt between us," the Hebrew expression, "to eat the salt of the palace," and the modern Persian phrase, "namak haram," which means untrue to salt, i.e., disloyal or ungrateful. In English, the term salt of the earth describes a person held in high esteem. Salt contributes greatly to our knowledge of the ancient highways of commerce. One of the oldest roads in Italy is the Via Salaria, which means salt route, over which Roman salt from Ostia was carried into other parts of Italy. Herodotus tells us of a caravan route that united the salt oases of the Libyan desert. The ancient trade between Aegean and the Black Sea coast of southern Russia was largely dependent on the salt ponds for evaporating seawater to obtain salt. At the mouth of the Dnieper River and on the saltfish brought from this district. China, the United States, India, Germany, Canada, and Australia are the world's largest salt producers in the early 21st century. Occurrence. Seawater. Through the material that gives seawater, though the material that gives seawater its salty flavour is composed of many substances, sodium chloride, or common salt, is by far the predominant compound. On the assumption that 1 gallon, about 4 litres, of seawater contains 0.231 pound, about 105 grams, of salt, and that rock salt on the average is 2.17 times as dense as water, it has been estimated that if the oceans of the world were completely dried up, they would yield at least 4.5 million cubic miles of rock salt, or about 14.5 times the bulk of the entire continent of Europe above the high water mark. Seawater contains on the average about 3% salt, although the actual concentration varies from about 1% in the polar seas to 5%. Enclosed waters such as the Mediterranean and Red Seas contain a higher proportion of salt than does the open ocean at the same latitude. Irrespective of the source of the seawater, salt obtained by the evaporation of seawater has the following composition: sodium chloride, 77.76%, magnesium chloride, 10.88%, magnesium sulfate, 4.74%, calcium sulfate, 3.60%, potassium chloride, 2.46%, magnesium bromide, 0.22%, and calcium carbonate, 0.34%. Natural brines. Brine in water containing a high concentration brine is water containing a high concentration of salt. Natural brines of commercial importance are found in the Dead Sea, as well as in Austria, France, Germany, India, the United States, and the United Kingdom. Salt in brines is nearly always accompanied by chlorides and sulfates of potassium, calcium, and magnesium. Carbonates and the element bromine are often are present as well. The Dead Sea, which covers an area of 1,020 square kilometers, that's 394 square miles, contains approximately, 12 billion 650 million tons of salt. The Jordan River, which contains only 35 parts of salt per 100,000 parts of water, adds 850,000 tons of salt to this total each year. The concentration of salts in the Dead Sea varies from 270 to 300 parts per 1,000 to a depth of 40 meters. That's 130 feet. It increases gradually from 40 to 100 meters. So that's 130 to 330 feet, and remains a fairly constant 332 parts per 1,000 below 100 meters. Dead Sea water is relatively free from sulfates and has a high proportion of potassium and bromine. Because atmospheric conditions favor evaporation by sunlight, solar evaporation, for about 8 months of the year, the production of salt, potassium, and bromine is feasible in the Dead Sea area. The process used for recovery of salt and potash is similar to that described below under salt manufacture. The Indian brines at Karagoda resemble seawater in the character of their dissolved salts, but are much more concentrated and in some cases virtually saturated. That is, they have dissolved all the salt they can. Certain natural brines occurring in the United Kingdom and the United States are of special interest because they contain salts such as the chlorides of barium and strontium. that are not usually found in brines. Special processing methods are required to produce salt from such brines. In Britain, these unusual brines are found at great depths during test drillings for petroleum, while in the United States, such brines occur in deep wells in several places. Rock salt. Rock salt is crystalline sodium chloride called halite by mineralogists. I think I've just destroyed that word. Mineralogists. Okay. You get me. It occurs widely in the form of rock masses and beds and is abundant in rocks from all geologic periods. Because of its great solubility in water, it occurs under extremely thick cover in humid regions, but lies close to the surface in arid regions. All major rock salt deposits originated from the evaporation of seawater at some time during the geologic past. Approximately 78% of the mineral matter in normal seawater is sodium chloride. Upon evaporation of about 9/10 of the volume of seawater, rock salt is precipitated. Calcium sulfate, gypsum and anhydrite, and potassium and magnesium salts also are precipitated. Deposits are found in beds from a few feet to many hundreds of feet thick. The ages of these beds range through much of geologic time. Because evaporation of a large quantity of seawater leaves only a small amount of salt, it is theorized that many extremely thick rock salt beds were deposited in partly enclosed arms of the seas in which evaporation was greater than the inflow of salt water. A barrier on the sea floor at the entrance to the basin prevented the outflow of the concentrated saline water. Such bedded salt deposits occur in the Punjab Salt Range in Pakistan and in Iran. However, these deposits have been little exploited. Similar deposits in the United States and Canada are worked extensively for both industrial and domestic use. Other important salt deposits, usually classified by the age of the surrounding rock, are found in Germany, Nova Scotia, the Subcarpathian region extending from Poland through Hungary and Romania, and the province of Sichuan in China, where salt wells have been in existence for more than 2,000 years. Another economically important type of rock salt deposit is the salt domes, which were formed when earth pressure forced up plugs of rock salt measuring approximately a mile across. The domes appear to result from pressure, which pushes the salt up through the rocks from depths as great as 50,000 feet, 15,000 meters. Many domes occur at shallow depths and are extensively mined. Domes in the Subcarpathian region of Europe have been worked since ancient times. The North German plain has many extensively mined domes, which are thought to have originated below 6,000 feet. Domes also are abundant along the US Gulf Coast. Rock salt may be obtained from domes by the usual mining methods or by drilling wells into the salt strata and pumping water down to dissolve the salt. The brine is then returned to the surface where it is processed like natural brine. Salt manufacture. At one time, almost all the salt used in commerce was produced from the evaporation of seawater, and sea salt still is a staple commodity in many maritime countries, especially where the climate is dry and the summer is long. Commercial salt is manufactured from rock salt as well as from seawater and other natural and artificial brines. Most of the artificial brines are obtained by pumping water into underground salt beds. A considerable amount of brine itself is used directly in industrial countries. Manufacture from rock salt. The beds of rock salt are mined or quarried by the usual excavation methods, depending on the depths and thicknesses of the deposits and on local conditions. The mined rock salt sometimes is dissolved and the salt manufactured by treatment of the brine as described below. The method affords opportunities for purification of the salt. When the rock salt is of a high degree of purity, as in Poland and the United States, the salt may be ground, screened, and marketed without further processing. The salt is mined in large lumps that are first crushed, then more finely ground, and screened by size into various grades. The salt is then bulk loaded into trucks, hoppers, or barges, or loaded into bags for further handling. Bulk handling has been greatly facilitated by the use of anti-caking agents, which allow the salt to be stored uncovered and outdoors without becoming a hard mass again. Manufacture from seawater and brines. Only a certain quantity of salt will dissolve in water at any given temperature. Once the solution contains as much salt as it can hold, it is said to be saturated. Any further additions of salt will not dissolve. Evaporation is the reverse of this process. When an aqueous solution of several salts, seawater for example, is evaporated, each of the salts precipitates as it reaches its point of saturation in the solution. Thus, the different salts in seawater will precipitate at different times, forming layers on the bottom of the evaporating pond. For seawater and many brines, the order of deposition is calcium carbonate, calcium sulfate, sodium chloride, magnesium sulfate, potassium magnesium chloride, and magnesium chloride. Solar evaporation. In maritime countries where there is a negative evaporation rate, i.e. the amount of water evaporating exceeds the amount of rainfall by at least 75 centimetres, about 30 inches, salt is produced by solar evaporation from seawater. The processes used are similar in general principle from country to country, but details of equipment vary from sophisticated in the United States to quite primitive in developing nations. A preliminary concentration is usually accomplished by allowing the seawater to flow through a series of gates constructed of wood or a combination of wood and concrete into a series of shallow ponds separated by dikes. In these ponds, a solution is concentrated to a specific gravity of about 1.22. This means that a given volume of brine is 1.22 times as dense as a given volume of pure water. At this stage, suspended impurities such as sand, clay, and the less soluble salts such as calcium carbonate or chalk and calcium sulfate are removed. Solar evaporation of the dead seawater is hastened by adding dye to the water. The dye permits more heat to be absorbed from sunlight in thinner layers of brine so that shallow ponds may be used and the penetration of brine into the ground is reduced. Once it has been concentrated, the brine is run through a series of crystallizing pans, usually 4 in number, where the salt is deposited as evaporation proceeds. In the first crystallizing pan, the brine is concentrated to a specific gravity of 1.23 and remains partly contaminated with calcium sulfate. The specific gravity of the solution in the pan increases slowly during crystallization of the salt, reaching 1.24 in the second pan. In the third pan, the specific gravity of the solution reaches 1.25, and the salt deposited there contains small amounts of magnesium sulfate as an impurity. The final solution, termed bitterns, has a specific gravity of 1.25 to 1.26 and is used in some countries, United States and Israel, in the manufacture of potash bromine, Epsom salts, which is magnesium sulfate, and magnesium chloride. In developing countries, the salt in each crystallizing pan is raked into rows where it is allowed to drain for several days. After that, it is collected into heaps, drained again, lifted from the pans, and finally dried. In industrial countries, the salt is harvested mechanically and washed with saturated brine. It is then dewatered, washed with fresh water, and stored for further processing or direct sale. Use of artificial heat. In areas where bedded deposits can be solution mined, evaporated salt is recovered from these solutions with artificial heat. Some evaporated salt also is made from natural brine or solar salt. Formerly, brine was concentrated in open pans over fire. More recently, steam-jacketed vessels have been used. The largest amount of salt produced in the colder climates is rock salt. The largest amount of evaporated salt is produced by multiple effect vacuum evaporators, and an important quantity is made in so-called open crystallizers or grainers that produce a type of crystal preferred for use in some of the food industries. The brine, natural or artificial, is first pumped into settling tanks where calcium and magnesium compounds may be removed by chemical treatment. In grainer operations, the settled and filtered brine is delivered to the grainer, a long open trough heated with steam coils. The brine is fed into the grainer at approximately the same rate at which evaporation is taking place and at a temperature only slightly below that of the brine in the grainer. The residue of brine, or bitterns, may be removed continuously, once a day, or less often. Evaporation occurs at the surface of the liquid, and the crystals originate there. They remain at the surface, held up by the surface tension of the brine. The crystal grows at the top edges, becoming a small inverted hollow pyramid, or hopper. Eventually, the hopper sinks and ceases to grow. When the crystals are recovered, the salt is largely in the form of flakes, hence the name flake salt. When multiple effect evaporators are used, the vacuum in each vessel is adjusted so that the vapor from the first vessel is hot enough to boil the brine in the second, the vapor from the second supplying the heat to operate the third vessel or effect. The brine is usually sent through the stages or effects in succession, although in the case of salt manufacture, fresh brine may be fed to each stage if desired. With open pans, 4,500 to 5,400 kilograms, that's 10,000 to 12,000 pounds, of steam are required to produce 900 kilograms, which is 1 ton, of salt. With triple effect evaporation, 630 kilograms, that's 1,400 pounds, of steam produce 1 ton of salt. The Alberga process is partially a vacuum pan and partially a grainer operation in which cubic crystals are formed in the solution fed to the grainer pans by a partial vacuum pan evaporation. These seed crystals in the grainer produce a salt that is a mixture of the grainer type flake and the flake grown on seed crystals. About 1,360 kilograms, that's 3,000 pounds, of steam are required to produce 1 ton of salt. Salt from the Alberga process is centrifuged, spun, from the brine and then dried. Table salt may have small amounts of aluminium calcium silicate, magnesium silicate, tricalcium silicate, magnesium carbonate, or tricalcium phosphate added to keep it free flowing. Iodized salt has potassium iodide added. In some countries, yellow prussiate of soda to prevent caking is added in minute amounts as regulated by the government.
Smooth